Some series to integral calculus. Some series to integral calculus, the arena in which we have waged a war. Right now, we are solving Fibonacci series. We will try to tackle logarithmic also, reverse fashion, Taylor series, Maclaurin series. If you give logarithmic series, then they would give you the sum series. Makes sense? I mean, if you give a formula of fx, then they will give you a summation of series. Okay, there is a Fourier series also. If you give a formula, then in terms of sinusoidal wave, they will give you a series again. So series is something that is mind blowing and it is there in mathematics. Why series is there? Because series helps a lot solving many problems. If I know that I can tackle any problem that is in polynomial equation, consider that I can tackle a problem if it is in polynomial equation. Then if I have a logarithmic, then I can show it in series of polynomial equation. And since I can tackle polynomial equation, I can tackle logarithmic. Similarly, Fourier also, if I can tackle sinusoidal wave, then I can represent any wave in series of sinusoidal wave and then with different phases, different amplitude and different frequency. In that manner, we can recreate the original signal through set of sinusoidal wave. If I know how to tackle sinusoidal wave, then any arbitrary signal I can distribute into series of sinusoidal wave and one by one I can tackle it. So series is a big thing. It's not a very small thing or minor thing in mathematics. Right now, we are in a phase of calculating summation of any series, summation of any series through summation of any series through integral calculus. This is what we are trying to achieve. Sum any series through integral calculus. And then now we are doing Fibonacci series. Fibonacci series is fx equal to fx minus 1 plus fx minus 2. Okay. This is x-axis. This is x-axis and this is y-axis. Now this is xy-axis. I have x equal to 0, 1, 2, 3, 4, 5, 6 and so on. At x equal to 1, x equal to 0. Okay, I can write bottom x equal to 0, x equal to 1, x equal to 2. At x equal to 0, I draw a vertical line. At x equal to 1, I draw a vertical line. At x equal to 2, I draw a vertical line. What is the height of those lines? That is called function over x. Because this axis as a y-axis, it is also called function over x-axis. Understandable? So this is also called function over x-axis. If I have x equal to 5 and at that point I have a vertical, then this vertical is function over x. This vertical is function over x at x equal to 5. I can write f bracket x bracket close at x equal to 5 or f5 whatsoever. That is the vertical value. Now if I talk about Fibonacci series, then fx at any x, what is the vertical? What is the height? That height is summation of previous two heights. If it is, I'm trying to get Fibonacci series at fx, then fx is the height at x. This fx is summation of fx minus 1 and fx minus 2. Whatever the vertical are this point, if I add these two vertical, it will become x vertical. What about fx plus 1? Then fx plus fx minus 1. What is fx plus 2? Fx plus 2, what is the height of the vertical? Then that is fx x plus 1 plus fx, something like that. Okay, then we have to start with the fixed number. So at x equal to 0, vertical is 0. There is no vertical. At x equal to 1, vertical is 1. When x equal to 2, then I can calculate now. When x equal to 2, vertical will be addition of these two vertical. Then it is again 1. X equal to 3, vertical is 2. 1 plus 1, 2. At x equal to 4, vertical is 3. X equal to 5, vertical is 3 plus 2, that is 5. X equal to 6, vertical is 5 plus 3, that is 8, and so on. Okay, this is called Fibonacci series. If I say x equal to n, x equal to 0, x equal to 1, x equal to 2, x equal to n. At x equal to n, I have a height called fn, function over n. Okay, what is the addition of all the verticals since from x equal to 0 to x equal to n? This is called summation series. I did not find anywhere where someone has computed summation of Fibonacci series, but I could find that I can represent Fibonacci series at x fx as not only fx minus 1 plus fx minus 2, rather than I can represent it through algebraic equation, and that equation is phi 1 to the power x minus phi 2 to the power x by square root of 5, where phi 1 is 1 plus a square root of 5 by 2 and phi 2 is 1 minus a square root of 5 by 2. Means phi 2 will be purely negative number for sure. Phi 1 will be purely positive number for sure. Phi 1 to the power x minus phi 2 to the power x by a square root of 5, by square root of 5. This is called Fibonacci number. This is called Fibonacci number at, or I can say at any x. What is the vertical? The vertical is phi to the power phi 1 to the power x minus phi 2 to the power x by factorial by square root of 5. Okay, that will be phi 1 is 1 plus a square root of 5 by 2. That will be more or less 1.6. And phi 2 will be 1 minus the square root of 5 by 2. That will be minus 0.6. That I can rewrite as minus 0.6 whole to the power x as minus 1 to the power x into 0.06, 0.6 to the power x. Makes sense? Now, whatever, if I'm trying to find the summation of up to n number in Fibonacci series, now I can divide into two parts. One is x is odd and one is x is even. If I say, can you calculate summation of Fibonacci series when up till x equal to x, then someone would ask your x is odd or even, because formula is different. If it is odd, then it is 1.6 to the power x plus 0.6 to the power x, because minus 1 to the power x will be negative plus. So 1.6 to the power x plus 0.6 to the power x divided by a square root of 5. If it is even number, then 1.6 to the power x minus 0.6 to the power x divided by a square root of 5. So you have to disclose your last number x or n is even or odd. Then only we can tell you what is the summation of the series. Anyway, that is the scenario. If I try to calculate odd number, then I have formula called 1.6 to the power x plus 0.6 to the power x by the square root of 5. 1.6 I can consider a and 0.6 I can consider b. 1 by a square root of 5 I can just forget it. Later we will add. Then a to the power x plus b to the power x if it is odd number. If it is even number, then a to the power x minus b to the power x. Okay, we will proceed with the successive approximation approach. This is what we have been doing. Successive approach. Successive approximation. What is successive approximation? Is that successive approximation means we will use calculus. We will use calculus to compute the summation. Okay, that's it. That is called successive approximation. Okay, what is summation? Summation means if I have x equal to n or x equal to x and this x is odd number, then summation of all the odd number, if I try to calculate, then it will be at x equal to 1, because 1 is odd number. At x equal to 1, what is the vertical? At x equal to 3, what is the vertical? At x equal to 5, what is the vertical? And at x equal to x, which is an odd number, what is the vertical? Okay, vertical is a to the power x plus b to the power x divided by square root of 5. That is the vertical. Okay, what you want? I want summation x equal to 1 to n. Next, where n is odd number. Summation x equal to 1 to n function over x, where function over x jumps every 2 fx plus fx plus fx plus fx plus fx plus fx at x equal to n or x equal to x whatsoever. It starts from x equal to 1, 3, 5, 7. It will sample at 2, not 1, 1. 1, 3, jump 2. Okay, if I connect all the top points at x equal to 1, x equal to 3, x equal to 5, then it will come up line like this. This is called function over x, and it is 1.6 to the power x plus 0.6 to the power x by a square root of 5, a to the power x plus b to the power x by a square root of 5. Okay, now how we can use calculus here? That is the question I understand that would be hitting everyone's mind. How to use calculus over here? Many times we have used it. To use calculus, which calculus you want to use? Perfectly here it would be, since it is summation, then probably we can use integral calculus. Integral calculus works only in area. If someone has area, then integral calculus works. I mean, integral calculus is nothing but multiplication of two items. If I have multiplication of two items, then I can draw graph of that item, where one item is x-axis and one item is y-axis. Multiplication of sin x with x means this is x-axis and another axis is sin x. How to multiply these two? I draw it. Okay, multiplication. Now someone will say, boss, I don't understand what are you doing. Sin x into x I want. Sin x into x I want. Okay, what do you mean sin x into x? Okay, now for simplicity, I can say I want 5 into x. 5 into x, then it is 5x. 5 into 4, then it is 20. 20. But if I do simple multiplication, that is rectangular, then I can draw 5 into 4. 4 is width and 5 is height. It will make a rectangle. If I draw it 5 into 4, 4 being x-axis and 5 being y-axis, it will draw a rectangle. And that rectangle area is 5 into 4. Means multiplication can be transformed into two sides of a graph, and then I can calculate the area. Simplest is the rectangle. If I say I want sin x into x, then if this is x-axis, then I can draw in similar manner sin x. Then what is sin x into x? Actually, it is area. If you mean it is area, then sin x into x from 0 to 2 pi should be 0. Yeah, it should be 0. Because left hand side we see positive and right hand side we see negative. So addition of both should be 0. Means area can be 0 whatsoever. Integral calculus is nothing but multiplication of two items. If I want multiplication of two items, take one as x-axis, take one as y-axis, draw the graph and calculate the area. Whatever area comes, that is the multiplication. So integral calculus is nothing but calculating multiplication of two items through area. What do you mean? If I say sin x into x or sin x dx, sin x dx from x equal to lower limit to higher limit, indirectly we are trying, if I have a sinusoidal wave, consider this is pi by 2. Here it is maximum. This is pi by 2. Then here it is maximum. If I say I want sin x dx, sin x into x can be written as sin x dx. This is the symbol of integration. This is how they chose. Differentiating it from normal multiplication. Sin x into dx, because if integration comes, multiplication will be calculated through area. Calculation of area. So if I say sin x dx and x is from x1 to x2. Consider this is x1 and this is x2 and this is pi. This is pi by 2. Then I can say that this area will be this area here under this sin x, whatever the area is, it will start from x1 and x2, whatever the area strip we are seeing, that is sin x dx x1 to x2. Means integral calculus calculate the area. Okay, the business of business of aeroplane has tire. When aeroplane lands or when aeroplane take off, then it runs on the runaway. It potentially runs on runaway. It has front tire, it has a rear tire, like a bus or truck or rail. The aeroplane runs on the track, and then when it catches some speed, then it takes off. While landing again it runs on the track, on the tire. Okay, but primary job of aeroplane is not running on the track. Primary job of aeroplane is to fly. Okay, so that is the situation. Now, if we talk about the integral calculus primary job is to work on area. Okay, it does multiplication, but it will happen only through area. Now, what I want? I want x equal to 1. At x equal to 1, what is fx in Fibonacci series? X equal to 3, what is fx? At x equal to 5, what is fx? At x equal to x, what is fx? Okay, then I have to add all the verticals, then I get the summation in terms of odd number. I get the summation in terms of odd number. Now consider I have an area strip. Now if this is x equal to 1 and this is x equal to 3, then in between I have an area strip. This area strip would go up and it would meet another continuous function. If I talk about fx, that is phi1 to the power x minus phi to the power x by square root of 5, that is a discrete function. Discrete function means function is generated by connecting the points, top points of all the vertical. If I connect, it generates a function that is fx. There is another function called gx, and this gx is arbitrary function that I don't know, but it is a continuous function. If I take x equal to 1 and x equal to 3, then there will be an area that will go like this and it will hit gx, and that area will be gx dx limit x equal to 1 to x equal to 3. Consider this area is same as left hand side vertical fx. If I had fx, the vertical fx at x equal to 1. What do you mean? I mean that every area, if I have n number of vertical, then I have n number of sub area. One sub area belong to left hand side fx. Means last area will be from, if I take up to n, the last sub area will be n to n plus 2. Okay, this what we have already done. One thing that we understand is area whatever we are taking, that will go and meet a hypothetical continuous function gx that will have width of 2. Okay, if x equal to 1, then width of 2 can be taken one left and one right of the x also. This is what we will tackle now. So if I take x equal to 1, and then if I take x equal to 1 minus 1 and x equal to 1 plus 1, then again there is an area strip of width 2 and it will go and hit gx. Okay, now I am saying actually I want summation of first all odd series where I have fx, or altogether. If I say altogether what I want, altogether I want summation of sigma, means sigma sign means summation, sigma x equal to 1 to n function over x, means function over x. If I do sampling of x equal to 1 2 3 4, then fx plus fx plus fx plus fx plus fx plus up to fn, where x is 1 2 3 4. Makes sense? Fx formula is phi1 to the power x minus phi2 to the power x by square root of 5. Okay, but problem is this fx is different for even number and odd number. This is what we saw. So we finalized to segregate it as odd number and even number. We are settling down odd number now. So for odd number, we have gap of 2, x equal to 1, 3, 5, 7, like that. And again, each x minus 1 and x plus 1, I take a width of 2 and draw a area. that go and hit gx. I'm trying to say fx at x equal to 1 equal to limit x equal to 1 minus 1 to x equal to 1 plus 1 means width of 2 gx dx plus x equal to 3 minus 1 3 plus 1 gx dx. All gx dx belongs to one vertical. One vertical. So if I say x equal to 1 minus 1 to 1 plus 1 gx dx, this vertical will match at x equal to 1. Fx equal to 1, fx at x equal to 1, that is 1, will be same as limit x equal to 1 minus 1, x equal to 1 plus 1. What do you mean? If I take any arbitrary x, then I have fx at that point, that is a to the power x plus b to the power x by square root of 5, where a is 1 plus square root of 5 by 2 and b is square root of 5 minus 1 by 2. Okay, now if I take any x, then if I take one left side and one right side, this area would go and hit gx, and that sub area will be same. What are I trying to do? I'm trying to do that if I have so many vertical in fx, each vertical height should be same as if I take minus 1 and plus 1 width of 2 area in gx. If that is the case, then fx at x equal to x, that is a to the power x plus b to the power x by square root of 5, will be equal to limit x minus 1 to x plus 1 gx dx. If I find gx in that manner, then full addition I can calculate limit x equal to 1 minus 1 to x equal to n plus 1, because last sub area will be n minus 1 to n plus 1. Right hand side we will keep, and first sub area is 1 minus 1, 1 plus 1. 1 minus 1 we will keep. 0 to n plus 1 gx dx. This full area will give the actual full summation, where each sub area is one vertical. Makes sense? Okay. Now we have fx as a to the power x plus b to the power x by the square root of 5. Now square root of 5, I am forgetting it. A to the power x plus b to the power x equal to gx dx. Then dx will be dfx by dx, means logarithmic of a into a to the power x plus logarithmic of b into b to the power x. Now let's start gx with that. Then integration will come as a to the power x by logarithmic of a. They will cut each other. At the end, it will come as a to the power x plus b to the power x. And then limit will be x minus 1 to x plus 1. Then the limit will be x minus 1 to x plus 1. We'll try a to the power x plus 1 minus x minus 1, a to the power x into a minus a to the power x into a to the power minus 1, x minus 1, a to the power minus 1, a to the power x, I can take it out, it will become a minus a to the power minus a minus 1 by a minus 1 by a. Similarly, plus b to the power x in bracket b minus 1 by b. Okay, this is what we are getting, but expectation it should be a to the power x plus b to the power x. So a minus 1 by a and b minus 1 by b is extra. So we will try again successive approximation. And now we will try gx. We will try gx with logarithmic of a by a minus 1 by a into a to the power x plus b plus b plus logarithmic of b by b minus 1 by b into b to the power x. This is gx. dx limit x minus 1 to x plus 1. If I try like this, then it would become a to the power x integration will be a to the power x by logarithmic of a. They will cut each other. Then a to the power x by a minus 1 by a plus b to the power x by b minus 1 by b. If I set limit x minus 1 to x plus 1, numerator will become a to the power x a minus 1 by a. They will cut each other. Finally, we will get a to the power x plus b to the power x. This is what is the wanted one. So we have found gx. If gx is logarithmic of a by a minus 1 by a and then whole into a to the power x plus logarithmic of b by b minus 1 by b into b to the power x, this is gx, then first integrate it and set limit x minus 1 to x plus 1, it will come as a to the power x plus b to the power x, that is the fx. Means at x equal to x, I have a height of ax, I have a height of ax, a to the power x plus b to the power x for odd number. This height will be exactly same as this area of this strip from x minus 1 to x plus 1, that will go and hit another function gx, and that is coming same as a to the power x plus b to the power x. Now, if I take summation of all the vertical, then I can take accordingly summation of all the sub area, because each sub area is exactly same as the vertical in between. So addition of all the vertical will be similar to addition of all the sub area. Sub area starts from x equal to 1 minus 1 to x equal to n plus 1. So now we can write that our odd number summation is x equal to 1 minus 1, that is 0. 0 to n plus 1, 0 to n plus 1 log a by a minus 1 by a to the power x plus log b by b minus 1 by b to the power x. Whole is multiplied by 1 by a square root of 5, that we have not forgotten. Anyway, we will try now. If I do integration, then a to the power x by logarithmic of a, they will cut each other. It will become a to the power x by a minus 1 by a plus b to the power x by b minus 1 by b, where a is 1.6 and b is 0.6. Limit is 0 to n plus 1. 0 also makes sense. So a to the power x will become a to the power n plus 1 minus a to the power 0, that is 1. So a to the power n plus 1 minus 1 makes sense, by a minus 1 by a. Okay, I think it is all right. So a to the power n plus 1 minus 1 by a minus 1 by a plus b to the power n plus 1 minus 1 by b minus 1 by b. Okay, this is what we get when we calculate the odd number summation. This is odd number summation. What about even number summation? Even number summation fx is different. Now fx is a to the power x minus b to the power, the first what we did, whole multiplied by 1 by a square root of 5, that we should not forget it. Anyway, now for even number, we have fx as a to the power x minus b to the power x by a square root of 5. Okay, here it is minus. If it is minus, we'll try gx now. If in similar manner, we will do gx as log a by a minus 1 by a to the power x minus log b by b minus 1 by b to the power x. If I do integration of this gx, then it will become a to the log a will go away, a to the power x by a to the power a by a minus 1 by a minus b to the power x by b minus 1 by b, and then limit is x minus 1 to x plus 1. Okay, then it will become a to the power x plus 1 minus a to the power x minus 1. A to the power x I can take outside, a minus 1 by a, they will cut each other, then a to the power x minus, this is what we want. More or less, this is perfect. So for even number, gx is log a by a minus 1 by a whole multiplied by a to the power x minus log b by b minus 1 by b whole multiplied by b to the power x. Okay, if I integrate with dx, it will become a to the power x by a minus 1 by a minus b to the power x by b minus 1 by b. Okay, limit is, what is the limit for even number? Even number starts from 2. So 2 minus 1, that will go as 1. And it will start from 0, but 0 we are not taking because 0 value is 0, 1. So we will start with 2. 2 minus 1 is 1. And end is n, where n is even number, n plus 1. So it will go from 1 to n plus 1. Limit is 1 to n plus 1. 1 to n plus 1, a to the power log a by 1 a minus 1 by a to the power x minus log b by b minus 1 by b to the power x dx. If I integrate, it will come as a to the power x by a minus 1 by a minus b to the power x by b minus 1 by b. Limit is 1 to n plus 1. That will come as a to the power n plus 1 minus a to the power 1 a to the power n plus 1 minus a to the power 1 by a minus 1 by a minus b to the power n plus 1 minus b to the power 1 by b minus 1 by b. This is what we get summation of even number. Now we have to add both to get the result. Okay, someone can try now. Now both n are different. In the odd number, we had a to the power n plus 1 minus 1 by a minus 1 by a plus b to the power n plus 1 minus, come down, minus 1 by b minus 1 by b. Whereas summation of even number is a to the power n plus 1 minus a to the power 1 by a minus 1 by a minus something like that. Whole is multiplied by 1 by a square root of 5. That we should not forget. But problem here is both n are not same. In the even number calculation, n is even. In odd number calculation, n is odd. If that is the case, consider that I am trying to calculate the summation of Fibonacci series up to n, x equal to n, where n is odd number. If n is odd number, then odd number will be more than previous number, the even number. What I am trying to say is, if I say summation of Fibonacci series where x is 33, then the last even number is 32, that is less than odd number. So in even number calculation, if I take n as odd number, then even number calculation n will be replaced by n minus 1. So it will become a to the power n plus 1, where n will be replaced by n minus 1. A to the power n minus a to the power 1 by a minus 1 by a minus b to the power n minus b to the power 1 by b minus 1 by b. This is what will come for the summation of even number. If I merge both to have the up to n number Fibonacci series addition, where n is odd number, it will come as 1 by a square root of 5. That is common to everything. And after that, in bracket, after that, a to the power n plus 1 come down minus 1, or a to the power 0 minus 1 by a minus 1 by a plus b to the power n plus 1 come down minus 1 by b minus 1 by b plus a to the power n minus a to the power 1 by a minus 1 by a minus b to the power n minus b to the power 1 by b minus 1 by b, 1 multiplied by 1 by square root of 5. This is what the result, that this is what is the summation of Fibonacci series if it is odd number, n is odd number. Now this can be taken as an assignment. What about if n is even number? Anyway, a is 1 plus a square root of 5 by 2 and b is a square root of 5 minus 1 by 2. Then this is what the expression will come, and quickly someone can settle it down in smaller term. Okay, because a by the denominator a minus 1 by a is common to two things, and b minus 1 by b is common to two things, that they can take and settle down the numerator. It will become smaller after that, and then someone can find the summation very quickly. Otherwise, it is very difficult. Very. First, you have to find all the Fibonacci series number, then you have to add it. So tough it is. Just quickly put n and you get the number. Someone can take it as an assignment. Consider the last term for the Fibonacci series is x is even number, not odd number. Then how someone can proceed here in calculating the final function where n is even number, and then someone has to merge odd and even number. This it can, someone can take it as an assignment. Okay, please do not mind supporting us. +91 is the India country code, 9483160610 is the telephone number. +91 is the India country code, 9483160610 telephone number. It is not available in any of the book. Anyone can try.